Good morning, everyone. First of all, I would like to introduce myself. I am P. Jashwant from BTech third year EC in NIT Andhra Pradesh. Today, I would like to explain about the bisection method in Python. These are the topics we are going to see in this entire presentation. Uh, First of all, let me go through the topics. Introduction, types of bisection process, problem, illustration of problem, iterations of minima and maxima, algorithm, Python code for minima and maxima, output for minima and maxima, Python code for plotting the graph, output graph, binary search, Python code for binary search, and its applications. Introduction for bisection process. The basic idea of the bisection method is to start with an interval a comma b that contains the maxima or minima of the equation, and then repeatedly divide the interval in half until the root is found with a desired level of accuracy. The midpoint of the interval is computed as a plus b by 2, and the sign of the function is evaluated at midpoint. Depending on the sign of the function at the midpoint, the algorithm selects either the left or right half of the interval for next iteration. This process will keep on repeating until the minimum or maximum is found with desired level of accuracy. Now let's discuss about the types of bisection process. There are two types of bisection process: numerical bisection process and optimization bisection process. Firstly, we go through numerical bisection process. This process is used to find the roots. It also divides the given interval into two. Then coming to optimization bisection process. This process is used to find minima and maxima of a given unimodal function. It also divides the given interval by a factor of 2 at each iteration. The basic idea of bisection process is, first of all, we have to select a uh, midpoint in the given interval. Let us suppose a comma b is the given interval. We are taking c, which is the midpoint of the given interval. We have to find the derivative of the function and substitute the midpoint in the derivative. And we have to check whether it is greater than 0 or less than 0. If it is greater than 0, then the interval will be updated to a comma c, or else updated to c comma p for minimum. And for maxima, then if the derivative of the function is less than 0, then it is updated to a comma c, or else c comma p. Let us go through the problem. We want to find the minima and maxima of a unimodal function f of x equals to x cubed minus 2x squared minus 4x plus 2 over the interval minus 5 comma 5. The function f of x is continuous and differentiable over the interval a comma b. The goal is to use the bisection method to find the minima and maxima of the function. Illustration. Now let us see how do we solve the problem. First of all, define f of x. We have to take the given objective function and find the derivative of f of x. We have to calculate the derivative of the objective function. Then next we have to calculate the c, which means midpoint. We have to take the midpoint of the given interval. And we have to check whether the point is greater than 0 or less than 0 after substituting in the derivative objective function. For minima, if f dash c is positive, then in the interval will be updated to a comma c. If not, interval will be updated to c comma. For maxima, if f dash c is positive, then interval will be updated with c comma b. If not, the interval will be updated to a comma c. This process will goes for n number of steps until the accurate maxima and minima is found. These are the iterations for minimum. First of all, we have selected the interval minus 5 to 5. Then we have got the midpoint 0, and we have substituted the point, that is minus 4. So our interval will be updated to 0, 5. Next midpoint will be 2.5 and derivative value is 4.5. We have to calculate until our desired minimum and maximum is found, or the interval is consistently small. Now next, let us see about iterations of maximum. This also follows the same process. Our desired interval is minus 5 comma 5, interval is 0, f dash is minus 4. Now the interval will be updated minus 5 comma 0 and the interval and midpoint of the interval will be minus 2. This also will come follow for n loops until the minima or maxima is found. Now let us see algorithm for writing the Python code for bisection process. First of all, we have to define the function f of x, and then we have to find the derivative of the given objective function. Next, we have to call the derivative of the bisection function which we have derived. Next, we have to select the midpoint from the given interval. We have to check whether f dash c is greater than or less than the selected interval. Then next, we have to set the input parameters like a, b, and tolerance. This is the Python code for minimum. And first step, we have defined the objective function. In the second step, we have find derivative of the function. In third step, we are calculating the midpoint and checking whether it is greater than or less than or 0. And uh, at last step, we have defined these parameters of a, b, tolerance. And last, we are calling the function. Python code for maximum. This also follows the same process. First we have to define f of x. Next we have to find the derivative of f of x. Next we have to calculate the midpoint and check the derivative at midpoint. And next we have to set the input parameters and call the function. Output for the above objective function. The minimum of x cube minus 2x square minus 4x plus 2 given interval is minus 5 comma 5 is 1.9, almost close to 2. Maximum of x cube minus 2x square minus 4x plus 2 in given interval minus 5 comma 5 is minus 0.67. Python code for plotting graph. Like this is the code for plotting the given objective function. This is the Python code for plotting the objective function. The graph of objective function looks like this. If we see here, the maxima is around 0.67 and the minimum is around 2. Next, let's come to binary search. Binary search is an application of binary bisection process. Binary search works by repeatedly dividing the interval into half. In binary search, the algorithm we use for target is sorted array or list. The idea to sort the entire repeatedly divide the search interval in half until the target value is found or determined. Binary search has a time complexity of big of log n, which means it makes it very efficient for searching large sorted arrays. Python code for binary search. The given question is to find the index of given element in the sorted list. The given array is 1, 3, 4, 6, 7, 9, 11, 13, 15, 17, 19. The given element k is 3. First of all, we have to set two values L at the starting of the array and H at the ending of the array. This loop runs until L is less than or equals to H. Next, we have to calculate the midpoint of the given interval. After that, you have to compare element with mth index to the element k and select the interval in which k lies. This process repeats until L is less than or equals to H. This is the code. The output for the above binary search is one. Now let's come to the applications of binary search and dissection method. Financial model. The bisection method can be used to calculate the yield and maturity of the bond or other financial instrument. This is an important metric for investors who want to determine the profitability of their investment. Engineering design. Engineers use this bisection method to optimize designs by finding the roots of equations and that describe the behavior of a system. For example, the method can be used to find the optimal dimensions of a bridge or other structure. Robotics. The bisection method can be used in robotics to calculate the inverse kinematics of a robot arm. This involves finding and joint angles that will position and affect the robot in a desired location. Thank you. From here, I would like to conclude this topic. Thank you for giving me this opportunity.